In the center of our sun is a black hole. Do some of my presentation now, but that's okay. You did really good at moving forward in your conclusions, and that's exactly what I concluded to. And this is one of the reasons I got kicked out of physics conference, is that I didn't just tell them the center of all galaxies were black hole. I told them all suns, including our sun, is a black hole, including planets, atoms. Everything we look at. The energy level of planets, for instance, all the gaseous planet in our solar system, all produce between 70 and 80% more energy than it receives from the sun. There is nothing in current physics that explains why. There's got to be an internal and energy producing dynamic that generates that, and I believe that's a black hole. Inside all orbiting bodies, you find the event horizon of a black hole, and depending if you're far enough from that event horizon, then you're far enough from the high gravitational field so that it is like the surface of this planet, a weak gravitation. Do you guys understand?
So, if that was the case, then would there actually be a solid core inside the crust, or would the crust be hollow? It would be like a sphere with a hollow inner with the black hole in the center. So
that's right.
Hollow Earth theory is what
hollow Earth, hollow sun, hollow galaxy, which we see, hollow atoms. We see that the atom is 99.9% space, and so on. Go ahead.
Do you think that this picture up here is also reproduced by the Big Bang itself?
Yeah, you could see. You see, if this cycle of a black hole gathering too much plasma and then spinning it out can be applied at all resolution of the fractal,
Goes all the way back.
then you could say that the Big Bang is just an enormous black hole that gathered too much material and eventually spit it out, and that created our universe. Do you see what I'm saying? And you can see it at all levels. You can see it in the creation of solar systems. You can see it even in the creation of atoms and so on. You know, at electron clouds orbitals jump from one quanta to the other if you add enough energy.
Well, then maybe you could use this pattern to predict the distribution of matter out there in the universe.
You can, and that's why we wrote the scaling law. That's the start of predicting the pattern of distribution of matter. First of all, you describe its scale.
It circles throughout the day.
Yes, you should see these circles throughout space. Yeah, is that what you're saying?
Yeah.
Yeah, we do.
I mean, all of it in this form.
Yeah, you will find. So the universe would have this form. Now, this form is not a 2D form. It's actually a 3D double torus, and we're going to see what that looks like in a minute.
Well, if you said people are black holes too, then why don't people gather too much material and then spit it out?
They do.
We do.
Was that like shedding your skin cells?
Yeah, the cell division is occurring at 1 million cells a second, I think. Okay, and you're shedding stuff all the time in order for your system to stay in balance. There's all sorts of ways you can look at it. For instance, throughout the day you radiate energy all the way throughout the day, and then as you radiate energy, you gather information,
And you gather food.
and so on, and all this stuff. Go ahead.
If the Earth would be hollow, would it have a nucleus in the middle?
The nucleus is singularity. The nucleus is from the event horizon of a black hole, from the surface of a black hole, everything inside there is collapsed towards singularity, leaving vacuum behind. So the center of the Earth would be a singularity. So would be the center of the solar system. the sun.
What you're saying is that singularity is basically infinite. You're
Yes.
infinitely moving towards a singular point that never really fully...
You never reach, because it has infinite potential of division. So, remember I was saying we all observe things from a different angle, so we're all different? But we all agree that this is a pan in general, Depending on what you've taken for breakfast, you might think it's a pink elephant, but that's a whole other story. But in general, we all agree that this is a pan. Why? Well, because although all of our heads, we're standing on a sphere, right? We're all standing on a sphere. And although all of our heads are diverging, right, to infinity, all of our feet are converging to the same singularity that links us all. So as far as the earth goes, from its point of observation, we are all agreeing on a consensus reality, which is constantly changing as a result of the way we're changing our relationship to reality on the surface. You guys see how that works? No?
No.
Oh my God. Okay, let me clarify that. Although we all have an individual way of observing the universe because we are all our own singularity. And when I say that, I don't say it trivially. If you are the singularity centering a universe, I mean it literally. If the universe is infinite, there is a universe out there that you are the perfect center of. Okay? So I'm not just making an allegory here. You are the center of the universe. But and then that universe that you're the center of, that is the center of even a larger one. And so on and so on. Well, okay. So now you observe the universe from your own center, but although you observe it from your own center, we are all connected to the same gravitational center, the center of the earth. The same singularity holds us all together. And that allows us to have a common agreement on the planet that this is a felt pen. Do you see? And not a pink elephant. Right? Otherwise, all of our views would diverge so far apart, we wouldn't agree on anything. You see? But the system is so that there is always a larger center that generates a consensus of observation between all the independent systems of that organization. For instance, all of your cells agree to be you, right? Because they're all held by a specific singularity gravitational center, which is you, right? And they all collaborate to generate you. Is that clearer now? Mm-hmm. There was a bunch of hands up. Go ahead.
Sorry, I just wanted to know that since you said atom is 99.999999 space,
yeah.
And if you say Earth is it's a black hole of atom, does that mean that Earth can have that much space in it?
Well, it does, because Earth is made out of atoms, and all the atoms are mostly space.
No,
but
in terms of the hollow Earth.
Yeah, well, I wouldn't say that the hollow Earth it has that much space. If there's a black hole at the center of the Earth, which I believe there is, it's fairly small, because it wouldn't take a very large black hole to generate the energy that we observe on Earth. Go ahead.
Could you describe the order of magnitude size of the event horizon of that black hole?
Of the black hole of the Earth?
Yeah, the range, perhaps, the limits?
Yeah, it would be in diameter. It would be very short. It would be, the size of a ball that big. It wouldn't be that big. Yeah.
on the order of half a meter or less to down to something like 0.
Yeah, exactly. Now it's not all done, that part, because we haven't made these calculations. We've made them for the sun and we've made them for other things, but we haven't made it for the Earth yet. But the theory would predict that there is a black hole at the center of the Earth, and that we're orbiting that black hole, but we're orbiting that black hole so far from it that we're in a place where there's weak gravitation, and we're far enough from the surface of the event horizon that the plasma had time to cool off, you see, that far from the event horizon, and it became more solid, you know, and that's why we have a crust around the black hole.
Is that plasma that you're relating to similar to what I read of Hawking radiation?
Yes.
Yeah.
Hawking radiation is the radiation on the surface of a black hole, but the Hawking radiation is really weak. The thing is that they're not calculating the plasma dynamics that are going along with the Hawking radiation. Meaning all the plasma, you know, being so close to a large gravitational field and all the thermodynamics effects and all the charge effects creates all this radioactivity, all this electromagnetic activity and all the radiation we see coming out of black holes. Go ahead in the back.
The previous computer frame looked at a glimpse. To me, my first impression was, or one of the impressions I had was, of magnetic flux lines around the Earth. And I'm sure that's no accident.
That's right. You're talking about the Coriolis effect. The Coriolis effect is very similar to this, and we'll see that in a minute. So you're right.
And that's the same that plays out in both magnetic and electronic flux lines.
Yes.
Wherever, however the magnitude, wherever.
Yeah, at any scale you find the same dynamics of the double torus and the structure of the vector equilibrium at singularity at all levels of the scale. So you'd expect the same dynamics to appear, and that's what we see. From electron cloud, probability clouds, to the clouds of a supernova, you know, up in the sky. So, you know, that's a span of a very large scale.
In that one, it almost looked one-dimensional, like it was a flat picture.
Yeah, but it's not.
Fact, it's completely full?
Yeah, yeah.
Okay.
And so after I saw all this and I was like all excited about the dynamics that we were being able to picture, it was nice to see this guy show up and in this conference and tell us exactly what it is about.
That is the result of a star that exploded in our own galaxy in the year 1054 AD. And as we watch these things explode and get bigger and bigger, they're beautiful to look at. By the way, the one in Babylon Cosmos in 1987 has evolved into a very interesting looking expanding remnant. If you look just at where the exploding star used to be now with Hubble Space Telescope, you see this rather strange looking structure. If you zoom in with Hubble Space Telescope and look at the remains of the 1987 supernova, here's what you see. And I'd like you to sigh again, please. That was better. Thank you. Okay, now what is this? I mean, it looks like sort of nested hula hoops. I mean, how did it possibly get that way? And there's a solid astrophysical answer for that. It's just two words, and it's nobody knows. There is no way anyone would have predicted a structure like this if it hadn't been observed by Hubble Space Telescope. So these remnants are very exotic things, but what they share in common.
Well, you know, he didn't know about my work, obviously, because I did predict it. And so, is this the right thing? I think so. So I thought that was interesting, you know. It was like, oh yeah, well, you know, I did talk about that, but one of the problems here is that the images are showing, like you were saying, a 2D type of structure, when actually we're talking about a spherical structure. Let me see.